Hello everyone. On this video we will look at how to find your exponential function when just giving either 1 or 2 points on a graph. Okay. Now our exponential functions usually have the form of y equals some value b to the power of x, or f of x equals some b to the power of x. But that's only when your coefficient is 1. Okay. Now if the coefficient is another value other than 1, then we have a generalized form that is pretty similar. We just added an additional value. So y equals a, so some value a times b to the power of x, or f of x equals some real number a times b to the power of x. So you see up here, if you had a equals 1, you still have b to the power of x. But if a is possibly any other value, then we write it in this general form. Let me scroll up a little bit. Okay, where a is any real number and b is your base. So your base will not equal 0, or your base cannot equal 1, because 0 to the power of any non-zero number is just going to be 0, and 1 to the power of any non-real number, well, to the power of any real number is going to be 1. So it's no point in writing 0 and 1 to, in exponential form when it's just 0 and 1. Okay, so we're dealing with numbers where your base is not equal to 0 and it's not equal to 1. All right, so if you are still writing, of course, feel free to press pause and finish up. But we're going to go ahead and move on to our first examples. And this is just basic evaluation of functions. Okay, so what if we let f of x equals 1/2 times 4 to the power of x minus 1? Evaluate f of 3 and write your answer as an ordered pair. Okay, so this is just to get you comfortable with exponential functions. Okay, so I'm going to go ahead and solve that. Okay, so of course we know that f of x is equal to 1/2 times 4x to the power of x minus 1. So let's say f of 3 is going to be equal to 1/2 times 4 to the power of 3 minus 1. Okay, so all we did was replace our x with 3. Okay, so that's going to be 1/2 times 4 to the power of 3 minus 1, which is 2. Okay, so 4 squared is 16. So you have 1/2 times 16. Remember, 4 squared is just 4 times 4. So 1/2 times 16 is equal to 8. Okay, so we know that f of 3 is equal to 8. But to write it as an ordered pair, this just shows that when x is equal to 3, your f of x is equal to 8. Okay, so this is your x, and this is your f of x. So when x is equal to 3, f of x is equal to 8. So this is really all that means. And this is your ordered pair answer. All right, so let's look at the problem here. So let f of x equals -8 times 2 to the power of 3x plus 3. Evaluate f of 0 and write your answer as an ordered pair. Okay, so what I want you to do is I want you to press pause and try to do this one on your own. All right, so I'm assuming you've paused it and worked this one out. So let's go ahead and verify. Okay, so we know that f of 0, remember that's just replacing your variable. If you had an r here, if this was f of r, then you'd replace the variable r. So this just tells you which variable to replace. So you have -8 times 2 to the 3 times 0 power plus 3, which is equal to -8 times 2 to the 0 power plus 3. Okay, so you want to remember any non-zero number to the power of 0 is just going to equal 1. So that means 2 to the power of 0 is equal to 1. Okay, so this is just negative 8 times 1 plus 3, which just becomes negative 8 plus 3, which is negative 5. Okay, so we know that f of 0 is equal to negative 5. So we write that as an ordered pair. When x is equal to 0, f of x is equal to negative 5. Okay, remember that's your x, that's your f of x, and when x equals 0, f of x equals negative 5. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so what if we have an exponential function that's y equals 20 times b to the power of x? And we know it contains the points 0, 20 and 1, 10. What is the value of b? Okay. So we know that for 0, 20 and 1, 10, we know that this is your x, y, x, y. Remember x and f of x and f of x. Remember that your f of x is just equal to y. So you can either use y or you can use f of x. Same thing. Okay. Now, we're first going to try this. Let's say x, and that's your y. Okay, so if you have 0, 20, which is of course your x, and your y, we're just going to plug it in. So you have y equals 20 times b to the power of x. We see that that just gives us, if our y is 20, we just replace y with 20. 20 equals 20 times b to the power of x, and your x is 0. Okay. Remember that b to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. So this just gives us 20 equals 20 times 1, which is 20. I mean, it's true, but it doesn't help us solve for b. It doesn't help us solve for b. Okay, so we do the same thing with the other one. Try 1, 10. Okay, so this is your x, and this is your y. Let me separate that a little bit. Okay, so once again, we have y equals 20 times b to the power of x. Let me clean that up a little. Here we go. Okay, so if we replace our x and our y, that gives us 10 equals 20 times b to the first power. And we know that b to the first power is just b. Anything to the first power is just that value. Okay, so if we divide both sides by 20, we get b is equal to 10 over 20, or 10 equal 20 equals b. Doesn't matter which way you write it. Which means if we simplify that, our b is equal to 1/2. Okay, so that means our y equals 20 times b to the power of x becomes y equals 20 times 1/2 to the power of x. Or you can write it as y equals 20 times 1/2 to the power of x. Either way, as long as you know that power of x goes next to the 1/2. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay. What if you wanted to construct an exponential function that contains the points 0, -2, and 3, -128? Okay, so if you have those 2 points, you know those 2 points are in your exponential function. I want you to go ahead and create the exponential function. Okay, so I want you to press pause and try this one on your own. All right, so assuming you've pressed pause, so let's go ahead and verify. So y equals a times b to the power of x. Okay, so we know that 0, -2 is your y-intercept. Okay, so that means when x equals 0, y equals -2. So we go ahead and plug those in right here. And what that does is, well, actually, you don't even have to plug it in. The reason why I told you that this is your y-intercept, and that was a really big hint, is that when you have your y-intercept, you know that your y value here is your a. And I'll show you why. Okay. So y equals -2 times b to the power of x. If you make x equals 0, you have b to the power of 0, which is 1. Okay, so you have -2 times 1, which is just -2. So when x equals 0, y equals -2, because this just becomes 1 and basically disappears. Okay, so when x equals 0, y equals -2. That's because you have y equals -2 to the b to the power of x. So you have y equals -2 times b to the power of 0 when x is equal to 0. B to the power of 0 is just 1. So you have y equals -2. Okay, so whenever you are given the y-intercept, you already know your y value is going to be your a. Okay, so that's a little trick so you don't have to go through a whole lot of work. Okay, so now what we're going to do is we're going to use this other one, and then we're going to substitute. Three -128 into y equals -2 b to the power of x. Because our goal for this one is to find b. Okay, so we know that this is our x and this is our y. So we go ahead and plug those into this one. Okay, so we have -128 equals -2 times b to the third power. So if we divide both sides by -2, we have b to the third power, because these two cancel out, equals -128 divided by -2, which is 64. Okay. Now for this one, you want to remember that 64 is equal to 4 to the third power, because it's 4 times 4 times 4 is 64. So you just rewrite this 64 as 4 to the third power equals b to the third power. Okay, so the only way this can be true is if b is equal to 4. So we see here that b is equal to 4. So we can go ahead and rewrite it. And y equals negative 2b to the power of x becomes y equals negative 2 times 4 to the power of x. Okay. But the trick is to remember right at the very beginning that whenever they give you, let me scroll this up a little bit, I'll bring it back down. Whenever they give you your y-intercept, you can always get your y value and replace it with a. Because when x is equal to 0, your a is the only thing that's left, which is your y-intercept. All right, so if you are still writing this, feel free to press pause, but we're going to go ahead and move on to our next example. All right, so let's say the graph of an exponential function has a y-intercept of 8 and contains the point 364. Find the exponential function that describes the graph. Okay. So what I want you to do is I want you to go ahead and press pause and try to find this one on your own. All right, so I'm assuming you've paused it and worked it out. So let's go ahead and verify. Okay, so we know that your y-intercept is 0, 8. When x is equal to 0, y is equal to 8. And x is equal to 0, y is equal to 8. Okay, so we know whenever we have your y-intercept, your y is equal to a. I mean, not y is equal to, your a is equal to your y. You might as well say it the other way. It doesn't matter really. Okay, so y equals ab power of x. Okay, so just to show you like the step-by-step instead of just telling you to remember it, replace x with 0 and y with 8. So you have 8 equals a times b to the power of 0. Okay, b to the power of 0 is 1. So again, 8 is equal to a. B to the power of 0 equals 1. Okay, so we know that we now y equals ab to the power of x becomes y equals 8 times b to the power of x. Okay, so now we have to solve for b. So we use the point 364 to solve for b. Okay, so we know that this is your x and this is your y. So we go ahead and plug those in. So we have 64 equals 8 times b to the third. Okay, so we divide both sides by 8. So we have 64 divided by 8 equals 8 divided by 8 b to the third. Anything divided by itself is just 1. So we have 64 divided by 8 equals b to the third. Or 64 divided by 8 is just 8. 8 equals b to the third. Okay. So you just have to remember 8 is equal to 2 to the third power. 2 times 2 times 2 is 8. So this, instead of 8 equals b to the third, you have 2 to the third equals b to the third. And the only way this will be true is if b is equal to 2. Okay, so we know that y equals 8 b to the x becomes y equals 8 times 2 to the power of x. All right. So if you are still writing, feel free to press pause and finish up. But we're going to go ahead and move on to our next example, which shows what to do when they don't give you a y-intercept. Okay, so what if we want to find the exponential function that contains the points 248 and 192? Okay, so first thing you're going to do is you're going to use the form y equals ab to the power of x to write two equations from the given points. Okay, so what we're going to do is we're going to have this one, the point 248, and the point 192. We're going to draw just a little line down the middle. Okay, so here we're going to use this for both sides. Remember, this is your x and this is your y. So we're going to have 48 equals a times b squared. And for this one, remember, this is your x and this is your y. So we're going to do the same thing, replace x and y. So we have 192 equals a times b to the third power. So what are we going to do from here? Well, for both, we're going to solve for a. And for this side, we're going to solve for a. Okay, so if we divide both sides by b squared, we have a, because b squared divided by b squared would just be 1. A equals 48 over b squared. And for this one, if we divide both sides by b to the third divided by b to the third will give us 1 over here. So we have a equals 192 divided by b to the third. Okay. Well, we have an a over here, and we have an a over here. Since a is equal to a, it would be, if you had 3 equals 3, 7 equals 7, 12 equals 12, a will equal a. That means this will equal this. So 48 over b squared will equal 192 over b to the third. Since both of those are equal to a, we just replace this one and this one. Okay, so what we do is we want to get rid of the denominator. We want to solve for our b. So since this b has the largest exponent, we're going to multiply both sides by b to the third. Okay, so if we multiply this side by b to the third, we get 48 b to the third over b squared equals 192, because if we multiply this by b to the third and this side by b to the third, This one, now let me clean that up a little. It looks a little bit messy. There, b to the third. This b to the third and this b to the third cancels out, leaving us with just 192. Okay, so now we go ahead and simplify this. We solve for b. B to the third divided by b squared is equal to b to the 3 minus 2, which is b to the first power, which is just b. Okay, so these two simplify to be just b. So you have 48b equals 192. Okay, so we go ahead and divide both sides by 48. Equals 192 divided by 48. So we know that b is equal to 4. Okay, so we have our b. Okay. So now we still have to solve for an actual value of a. So we can plug into either a equals 48 over b squared, or a equals 192 over b to the third. Okay, so we have our b value. We just have to plug it into either to solve for our a, and I'll plug it into this one just because it looks easier. No other reason than that. If you want to plug it into this one, you'll get the same answer for a. Okay, so if you have a equals 48 over b squared, then that's going to equal 48 over 4 squared, since b is equal to 4, which is 48 over 16. So that means that your a will equal 3. Okay, so we have our a, we have our b. We just go ahead and replace that. So y equals ab to the power of x becomes y equals 3 times 4 to the power of x, which is your equation. Okay, so remember, first thing we did, we got our 2 points. Let me rule this up just for a second. Okay, so remember, the first thing we did is we grabbed our 2 points and plugged them into our general equation. Then we solve for a. Okay, then once we solve for a, we just made those two equal, and we solve for b. Then once we got our b value, we just plugged our b value into either one of those to give us an a value. Then once we have our a and our b, we just plug them into here. All right. So if you are still writing, of course, feel free to press pause and finish up. But we're going to go ahead and move on to our last example. Okay, so the graph of the exponential function passes through the points 110 and 480. Find the function that describes the graph. Okay, so what I want you to do is, using the exact same method as the previous example, is press pause and try to solve this one on your own. Excuse me. All right, so I'm assuming you've pressed pause and worked this one out. So let's go ahead and verify. So we have y equals a times b to the power of x. So we have our point here. We have 110. We have our point 480. And again, just draw a little line separating them. Okay, so remember, this is your x, this is your y, this is your x, and this is your y. And we're going to plug those into this one. Okay, so this is 10 equals a times b to the first power. And this is 80 equals a times b to the fourth power. Okay, of course, now we just solve for a. Okay, so if we divide this side, both sides, by b to the first power, or just b, we end up with a equals 10 over b. And this side, if we divide both sides by b to the fourth, we end up with a equals 80 over b to the fourth. And of course, since a is equal to a, that means that 10 over b is equal to 80 over b to the fourth, since you have an a equals a. Okay. So since b to the fourth has the highest exponent, we're going to multiply both sides by b to the fourth. So let me just move that a little bit. So we have b to the fourth, and let me move this over a little. And b to the fourth. And again, these two are going to cancel each other out. So you end up with 10 times b to the fourth divided by b is equal to 80. Okay. So we know that b to the fourth divided by b to the first power, which all this is b to the first power, is equal to b to the 4 minus 1, which is b to the third power. Okay, so that means this becomes 10 times b to the third power equals 80. Divide both sides by 10. We have b to the third power equals 8. Okay. Well, we have to remember that 8 is just 2 to the third power. That means b to the third power equals 2 to the third power. So the only way this could be true is if b is equal to 2. Okay. Now that we have our b value, we just plug this into either a equals 10 over b or a equals 80 over b to the fourth. And again, you can plug it into either one and get the same answer, but always pick the one that looks the easiest. So we have 10 over b. Okay, so that means that a equals 10 over b. Let me kind of separate this a little bit to avoid confusion. A equals 10 over b means that you have 10 over 2. So a is equal to 5. Okay, so you have your a, you have your b, just plug it into your equation, your general equation. So y equals ab to the power of x becomes y equals 5 times 2 to the power of x. And that is your exponential function that describes this particular graph. All right, so hopefully this made sense, and I will see you on the next video.